Hello students, I hope you have watched all three different previous videos and you have understood certain methods involved in plotting the Nyquist plot for stability analysis. So now this is another problem which is quite different to what we solved in the previous three videos. Okay, now this is the given problem. Is there any pole at the origin? There is no pole at the origin, therefore the contour diagram is, the initial foundation diagram is. So we don't have E, F and all in this particular problem. So we have A, B, C, D and A. Okay. So this is A, B, C, D plus G infinity 90 degree, 0 degree, minus 90 degree, and this is attaining infinity. Okay. Now here omega equals 0 and here omega equals infinity and here is omega equals minus infinity. Now pole 0 diagram and check the value of P. So here we have one pole at -2, one pole at +2, sorry, because it is S -2 and S -4. Therefore, we have one pole at +2, one pole at +4, and then we have one 0 at -3, another 0 at -5. Okay, so we have two poles in the right half of this plane. Therefore, the value of capital P is actually equal to 2. So, as P is not equal to 0, the open loop control system is unstable. It's not stable. So, in this problem, as we have poles towards right half of S plane, we have two poles at the right half of S plane. Therefore, the open loop control system is unstable. Okay. Now let us move on further. Let us find the encirclement. To find the encirclement, we need to go with three traces now. So one is path AB. Let us first do it for path AB. So let us take the equation G of S into H of S, which is given as K into S plus 3 into S plus 5 divided by S minus 2 into S minus 4. Okay. Now let us write the magnitude and angle equation. So magnitude and angle equation is what we need here. So magnitude of K is K. Angle of K is 0 degree. Okay, let me not write that. Now magnitude of S plus 3 is, because we need to substitute S as j omega plus 3 into the magnitude. See, this is K. We need to put S equals j omega, right? K into j omega plus 3 into j omega plus 5. We need to put S equals j omega. So therefore, this is the equation you get, j omega minus 4. Okay. So magnitude of j omega plus 3 is omega square plus 9 into tan inverse of omega by 3. Okay. Similarly, the magnitude of S plus 5 is square root of omega square plus 25 into tan inverse of omega by 5 divided by the square root of omega square plus 4 into tan inverse of minus omega by 2 because negative is there, and square root of omega square plus 16 because 4 is 16 minus 4 square is 16 into tan inverse of minus omega by 4. So these are the angles which we normally take. Now let me tell you, like tan inverse of minus theta equals 180 minus tan inverse of theta. It is what we normally take in right angles. So therefore, I put all the magnitude parts separate and all the angle parts separate. So what I get here is k into square root of omega square plus 9 into omega square plus 25 divided by omega square plus 4 into omega square plus 16, and this into the angle part is tan inverse of omega by 3, tan inverse of omega by 5 divided by tan inverse of, so 180 minus tan inverse of omega by 2. Similarly here this is 180 minus tan inverse of omega by 4. So if I write it properly, what I get here is, so anyway, I'll try to take at A. At A, we know that omega equals 0. Therefore, what do we get here is k into square root of 0 plus 9 is square root of 9, which is 3, into square root of 0 plus 25, square root of 25, which is 5. One thing divided by square root of 0 plus 4 is square root of 4, which is 2, into square root of 16, because 0 plus 16 is square root of 16, which is 4, into tan inverse of 0 by 3 is 0, tan inverse of 0 by 5 is 0. All this becomes 0, only 180 and plus 180 becomes, so minus 180, because it is denominator, when it goes to the numerator it becomes minus 180, minus 180. So therefore, finally what do we get here is, we have k, 5 3s are 15, 15k divided by 8 is the magnitude at an angle minus 360 degree. 180 plus 180 is minus 360 degree at A. So this is at A. At A is this. Whereas at B, omega equals infinity. So what happens here is, the magnitude is, the magnitude is infinite. So this becomes infinity, this becomes infinity. So let me tell you that k into infinity divided by infinity into infinity, and angle is tan inverse of infinity is 90 degree, 180 degree, minus 90 degree, 180 degree, minus 90 degree. So therefore what do we get here is, all this infinity will get cancelled. So the magnitude is k is this at an angle, 90 plus 90 is 180. So this minus 180 goes to the numerator, so minus 180. This becomes plus 90. This becomes minus 180. And this becomes, when it goes to the numerator, it becomes plus 90. So 180 minus 180, and 90 plus 90 is 180, and this 180 gets there. So therefore, you'll end up in getting 0 degree. So at B, the value is k at an angle 0 degree. K at an angle 0 degree. So if I try to write this contour in our diagram, what do we get here is, so at A, it is k by, at A it is 15k by 8, 15k by 8 at an angle minus 360. So we know that angle minus 360 is somewhere here. So this is minus 360. So this is minus 360 angle. And at A, if it is minus 360 degrees, so like, let me take this is A dash, and the range from here to here is 15k by 8. So that is the magnitude we got at A. So from here to here is 15k divided by 8. Whereas at B, the magnitude is k, right? At B, the magnitude is k. So I can say that somewhere here, the B, where the magnitude is k. I'll just roughly take that, because 15 by 8, we know that 15 by 8 is what? Let me tell 15 by 8, which is 1 point. 15 minus 8 is 7. So 1.8 K. Okay. If I say from year to year it is 1.8 K, so I'll write it as 1.8 K only. So from there to there, if I say it is 1.8 K, definitely B, which I am taking here, which is B dash, definitely it will be from here to here it is K. Okay, B is not at origin now, it is at K. But angle is 0 degree. So angle is 0 degree means this one. Angle is 0 degree means this, this one only. Minus 360 degree and 0 degree are on the same line. Right? Because this side it is minus 180. So therefore minus 360 degree and 0 degree is in the same direction. But it is K. But what you need to do is, you need to go from 0 degree and then minus 360 degree. Keep that in mind. So I need to traverse from 0. So this is very good, some information which you need to think here. I need to traverse from 0 degree and go to minus 360 degree. If it is B dash to A dash. But I need to traverse from minus 360 degree and go to 0 degree. Because I am going from A dash to B dash. So if I want to go from minus 360 to 0, in what direction I should go? That is very important. Okay. From minus 360 degree to 0. So this is minus 360, this is minus 90, minus 180. This is minus 270. I cannot go towards minus 360, minus 90, minus 180. I should go from minus 360, minus 270, minus 180, and then to 0. Minus 90 and then 20. So therefore, the contour should come like this. It will go to minus 270, and then I should go to minus 180, and then 90, and then back to 0. So this is the contour, Nyquist plot. I hope you got it what I'm saying. I should start from minus 360 degree from A dash, and I should take a path to B dash, which I should reach minus 360. So from minus 360, if I want to go back to 0 degree, I should traverse the path minus 270, minus 180, minus 90, and then 0. Hope you understood. This is the path which we need to take. Okay. Now let me go with section 2. Section 2, traversing the path B, C, and D. B, C, and D. Again, we'll take the same equation which we got earlier, which is G of S into H of S equals K into S plus 3 into S plus 5 divided by S minus 2 into S minus 4. Now, in this particular step, what we need to do here is, we need to replace S with limit r tends to infinity, r into e power j theta. If I do that, what will I get here is limit r tends to infinity, k into r into e power j theta plus 3 into r into e power j theta plus 5, okay, divided by r into e power j theta minus 2, r into e power j theta minus 4. As r tends to infinity, this r into e power j theta, r into e power j theta, r into e power j theta, r into e power j theta. So that remains as, so it is limit r tends to infinity, k into r e power j theta, divided by r e power j theta, If you see here, all these are getting cancelled. So therefore, I am going to get only the parameter limit r tends to infinity k. So this can be written as k, because r tends to infinity cannot be applied. I'll write k at an angle 0. K at an angle 0. Okay. Now, let us go with further path. Is there any path that we need to go with? That is section 3, last section. Section 3, which is, anyway, this is k at an angle 0. You need not to, if I write this, very simple. So I'll just write. So this is your path. Now k is the magnitude at 0 degree. So this is 0 degree and the magnitude k is this. Now this is the place where your b dash, c dash, d dash will now come. So it is not 0. Magnitude is not 0 now. Magnitude is k. So therefore, this is the place where k comes into it. So this is k. So b dash, d dash, c dash will come here. Now section 3, which is path d to a, and I told you this path is the mirror counter of a to b. So what do we have here is, so B to A we had in this direction, now we have in this direction. So that is what we did. So now what do we do? The path goes in this direction. Path goes like this, like this, like this. So this was the path which we wrote mirror for this path. Okay. So now this is your D dash, this is the A dash, and the direction is from D dash to A dash. And this was from, we took from A dash to B dash. So this path will go in this direction. And this path will go in this direction. Okay. Okay, now we will write the final trace by combining all three. So we had points at K, which is B dash, C dash, D dash. We had this point. The range here is K till here. Now we had A dash point. The range here is 1.8K or 15K by 8. It's clear. Now we have a curve which we need to write. So we had a curve which was coming from A dash to B dash like this, and we had a curve which was going from D dash going on the same line like this, and it is going to A dash. Okay, and the direction of this is in this direction, and this is in this direction. And here it is, if it was coming like this and going in this direction, and this was, going in this direction, it is going and meeting to A dash. So this is what the final contour for this particular problem. Okay. Again, now we don't know whether minus 1 plus 0j is encircled by these circles. So let me take this as x dash, and the distance between this to this is, let me take as m. Let me take as m. Okay. Now I need to find out the value of m. Means the point at x dash. What is the value? Okay. So to do that, as earlier we did angle condition. So we need to know what is the total angle formula that we have already written earlier. Here, if you see here, this is the angle formula that we get. So it is tan inverse of omega by 3. The angle formula is tan inverse of omega by 3. Okay. Now if you go and see, so what I'll do, I'll just copy this and paste it there. So I'll copy this complete thing and copy this, paste it here. Okay, so I'll just remove this. Now this is the angle term which we have got. What I'll do is I'll write this should be equal to minus 180 at x dash. This should be equal to minus 180 at x dash. So what would be the final formula? This 180 and 180, if it goes to the numerator, it becomes minus 360 and plus tan inverse of omega by 3 plus tan inverse of omega by 5, and this minus tan inverse of omega by 2, it becomes plus tan inverse of omega by 2, it goes to the numerator, and this minus tan inverse of pi by 4 which becomes plus tan inverse of omega by 4 if it goes to the numerator. And this is equal to minus 180 degree at x dash. At x dash. Now if you try to find out the omega value for this particular problem, if you for this particular angle condition, if you try to find out the omega value by applying the tan inverse of x plus tan inverse of y formula and all, the omega value what I get here is square root of 11 radians per second. So therefore, at x equals at x dash, the omega value is actually equal to root of 11. Now I need to take the magnitude of gh of j omega. So when I take the magnitude equation, the magnitude is what we did earlier, which we have found earlier. So this is the magnitude. This is the magnitude equation. So let me take that magnitude and copy it at the bottom. So this is the magnitude, overall magnitude that we got. So I take it to the bottom. I'll paste it here. Okay. Now this is the total magnitude equation which we have got. Now you need to substitute omega to be equal to root 11. So what I get here is when I substitute omega equals root 11. So k into 11 plus 9 because omega square. So root 11 square is 11 plus 9 into 11 plus 25 divided by square root of 11 plus 4 into square root of 11 plus 16. If you solve this completely, the magnitude at, so that is value of m which I told you earlier, the magnitude of at x dash, the magnitude value will be 1.33k, 1.33k. So it means that this point, whatever I am saying, this point is actually 1.33k, 1.33k. Now I need to check about the stability now. Earlier we came to know that for this problem we got p equals 2. So see both the encirclements are anti-clockwise. If you see here, this is also anti-clockwise, going in a reverse direction. This encirclement is also anti-clockwise. So therefore n is equal to minus 2 if these encirclements will cover minus 1 plus 0j. Okay, if it covers minus 1 plus 0j, then the encirclement will be equal to 2 and negative 2 because both are anti-clockwise. So when do we get this minus 2? When do we get n equals minus 2? It all depends on this 1.33k. 1.33k should be less than 1, which we all know should be less than, now the encirclement should be outside this particular, inside this particular circle. So somewhere I should be having this point where from this point to this point should be, minus 1 should come somewhere here. So definitely 1.33k should be not less than 1, it should be greater than 1. It should be greater than 1. The point 1.33k should be greater than 1. Why? Because this minus 1, if it should come inside this, then this point should be greater than this 1. Okay, so therefore 1.33k should be greater than 1. If you solve this, k should be greater than 0.75. If k is greater than 0.75, I am able to get n equals minus 2. Therefore my z will be equal to p plus n, which is p is 2, n is minus 2, which will be giving me 0. So therefore, what I should keep in mind is k should be greater than anything value of 0.75 should be greater than 0.75 and should be less than infinity. Now this is the range of k for the system to be stable. This question can also be asked for you, like, find out the range of k for the system to be stable. See, they don't only ask you to plot the Nyquist contour, they might also ask you to find out the condition of k value so that the system becomes stable. So that can also be asked. And the last prediction which I did is what, the prediction what we do for finding the value of range k. Okay, I hope you understood this problem. This was quite different. And we also had two encirclements here. And these two encirclements are anti-clockwise. Now we wanted to find the point x dash. Now what would be the value for x dash? We got 1.33k. Now anything, if I want to make this system to be stable, I need the condition for n to be equal to minus 2. So when I want n equals minus 2, minus 1 plus 0j point should be within the encirclement. So therefore, definitely at point x dash, the value should be greater than 1. So it means that 1.33 times k should be greater than 1. Due to which I got k should be greater than 0.75. So anything greater than 0.75. So therefore, the range of k can be like k can be greater than 0.75 and less than infinity so that the system becomes stable because P is equal to 2 and N equals minus 2. So both get cancelled and Z becomes 0. Okay. So this problem, it is unstable for open loop. It becomes stable for closed loop only when K is greater than 0.75 and less than infinity. Okay. So I hope you understood this. And with all these four videos, I hope you understood Nyquist stability criteria and how to comment on stability in much clear way. Okay. So thank you all.